Namaste and welcome everyone. I hope you had an attempt did an attempt for the previous exercise, the vending machine, um, and at least thought about the problem. Today we are going to continue with the vending machine, trying to we'll try to make the class more interactive, where I try some parts of the vending machine and then you try other parts as well. Before we do that, if there are any comments or anything else you would like me to look at, please let me know. So you could use the chat and express any concern or anything else that you would like me to look at. Okay, so okay, welcome everyone once again. So today we'll just go into the vending machine, back to the vending machine. Let me just share my screen now. Okay, so sharing my screen, and just a review of what we did the last time. I mean, our previous sessions, we've focused a lot on functions and loops, and we discussed this cashier program, and we also planned to use the cashier program while attempting the vending machine. Um, those of you attending, could you please just mention in the chat, like if you attempted the vending machine or you are midway through, or some functions are working, some type of progress in the chat, then I would know where you are, and then we can continue basically. Okay, so first we'll just continue with the vending machine, and okay, so thanks Kelvin. So Kelvin has given some solutions, and and Yin Chen as well. So Hillary is trying to understand the object-oriented code before attempting it. Actually, the vending machine is not supposed to be attempted in the object-oriented. Okay, so that exercise 2 is without object-oriented, and then in exercise 3 you are going to re-implement that vending machine using object-oriented programming. Okay, so we'll just carry on here, and Kelvin, I will pull your solution and merge it into the repository after the class. So if you go into the previous exercises, you can see part 1, and there's solution by Kelvin here. So other people can also give their solution. So just need to pull a pull request, do a pull request, and push there. And then Kelvin has tried this too. And part 3. So there's some solutions. The prime one is done. Part 4 is also solution. And part 5, and the maze navigation. So the solution is there. So either it's entirely correct or partially correct, I haven't checked. I've been just preparing for the class, but we can at some point of time go back and run these solutions and then critique it. Okay, so now we move into the vending machine problem, and this is what you are supposed to do. Right, so we planned the vending machine in the previous lesson. So go. So it's Python. Those of you who have already attempted it, we'll go one by one. So basically, the machine is asking for some amount, right? So right, if you have attempted the show menu, could you please paste your solution for show menu in the chat? Or paste a link. If you can also paste a link to the GitHub repo if you have pushed it, like copy the line link to the repo. Okay, so let's all take some time. I give you some time to start thinking, start implementing a show menu, which is partially implemented, and make selection. Okay, so your make selection is implemented, but it's not being called anywhere. So the first thing is should be in your machine should be your make selection, right? So you're telling, so at the moment the make selection basically shows Coke, water. So I want you to try to finish the make selection. By finishing it, you need to fill the rest of these things here. And as soon as you update this one, just paste it in the chat. Then I'll just copy what you paste in the chat and try it here. Okay. So we try to make this more interactive. And if anybody wants to share their screen and show their progress, then you're also welcome to do. And then I can critique. So we want to ask the user to enter the number of items, right? Before make selection, we should say something. So basically, that's how we start. So the item names are there, the number of items and price. So the make selection is called basically. It just should give the show menu. Now here we want to ask the user to enter. Anybody tried the make selection? Please paste your attempt in the chat. So so we're giving some instructions to the user. Can you tell me what are the rest of the items? Let's just fill the names. Put it in the chat because I will have to open the window. Oh, what are the rest of the items in the menu? In the chat, anybody? What's the third item? So let's say first is Coke, second is water. Okay, thanks, Megan. So first is water. Okay, so first is water. So I'm wrong. Anybody tried the insert? Sorry, make selection. You can put your code on the in the chat. So diet coke. So these are the items. This machine is not a very healthy outlet. You have all the wrong things there. I mean, most of the wrong things there, except for water. A lot of sugar, basically. Bubble gum is a major problem for. Has been a major problem in some countries, probably banned as well. It was used to be a major problem in Fiji when I was growing up. You go to the bus and somebody places a bubble gum on the seat, that kind of thing. And then it takes time for it to be part of the environment. I mean, other species choke on it. So, okay, so cost is not defined. Yeah, so, okay, now at least we can see that our item list has all the things there. I think one more thing we need to do probably, we need to print this in a nice way. Okay, at the moment it's not telling much. So basically, let's say that if we want to print this in a nice way, what would we do? We would use a for loop, right? So we would use a for loop, and it will be something like that. For loop, and we place that for loop there, and we want to be printed next to each other, let's say, and we can just put any of the things there in the length, and then we don't have to tell these things right now. Let's so so firstly we need to print the item name. Okay, then afterwards, before that, we should print the item ID. That's I plus 1 because it will start from 0. We want it to start from 1 because the 0 is not a good way to tell people to pick. It's okay, but this is more informative. Okay, ID. So it just says ID, and then basically right? So did anybody do it this way? Let's say see what it does. Okay, so now we have this in the vending machine. So how can we make it so that they all come in the same line? Okay, probably we can just put it in here this way. Right. So we have the ID is one, and perhaps it's better we just put this also in the same. mm, let's see what it looks like. You can see the now our show menu is becoming much better, more informative. Okay, now we see ID and what rather than ID, we can just say, probably that would be understood. Okay, so that's quite good. We can live with this. Some of them not nicely written. Bubble gum. I wonder about if bubble gum is still legally sold in Australia. I wonder. This used to be a big problem back in the days. Okay, so now we see the item, and basically we can, because the end one is the price, we could always we can always separate some of these things, such as you know we can make this look a bit better by putting things like this where it's now separating, and basically here, here we can say cents, so we just assume that our machine payment system is in cents, but it got upset for some reason. We have to see why. Okay, it got upset. Um, you shouldn't make the Python interpreter upset too much. Just kidding. It doesn't matter. You can make it doesn't really care. You can try hundreds of times, and if you don't listen, follow Python's instructions, it will not run it. Okay? So we have to follow instructions. Okay, so now we have a proper menu, right? So it's basically another item. It's 75 cents, this and that. So are you guys happy with this menu? Um, say it in the chat if you like it. Or it's okay. Anybody okay with it? Nobody is okay with the menu. So any comments about the menu? Are you happy with the menu? Okay, let's move on. I assume that no comment means you are okay. So now we want the user to enter, right? So anybody tried this part already where the user enters things like this and uh, something like that. So this is We call it the selection. And, okay, this should be the said input here, right? Will that work? Experts and across the board is working on finalising our road. Mute everybody.
You're on mute. Rohit, you're on mute.
Okay, sorry. Thanks, Hillary. So let's, I give you 5 minutes, you implement this from here, and then we share, we can see your screen if you want, or place your code in the chat so that we can see, and we want you to try, and it doesn't necessarily have to be, let me just push this, a code, it can be just an algorithm or some ideas. So let's take the next 5 minutes and work and complete this. So let me just push this quickly. I'll just put VM in there. Okay. Right. So I'll give you 5 minutes and continue with my morning tea. Hakim, is there anything you tried which I need to merge this pull request? Okay, I'll just leave this as it is. Okay, so anybody wants to give it a try? Let's see the chat, or you need more time. Just mention in the chat. Any attempts so far? So at the moment, at least we're getting things from the user. Which is not a big deal. Anyone? Nobody tried? Okay, we don't have that much time, so we better carry on. Um, to actually solve this issue, it's better we see some previous exercises. Remember, we were doing this decimal to binary and how the numbers were kind of taken out. Where else we were doing something where the numbers were we were disintegrating the numbers. That's what we need to do here. Okay, we need to disintegrate the numbers essentially. Okay, I recall we did this example about Armstrong numbers, right? And basically there we were disintegrating the numbers, right? So that's the loop there. So let me just copy that loop and paste it here. So let's copy and paste that and see what's going on here. So let's say your selection, we just call it selection temp, and we don't want to do any order or anything. We do not want to calculate any sum. We just want to see what our digits are. Okay, so let's just run this. Got upset. Okay, because my indentation is not right. So we just want to compute what's the total cost. Right, so let's say we say 1122, and so for 1122 we could see 2211. That was just what's printed, and we just use the same code that was used by for computing the Armstrong number. But are we printing it, computing it from the back or from the front? So because we have 1 to 1, 1 to 3, 112, but you have 2 1 1, 3 2 2 2 1 3 2. So it's just printing it from the back. So basically it's taking one number at a time. This is taken out, this is taken out, this is taken out, right? This is taken out, this is taken out, and then finally the last one is taken out. So now we can see that we see the digits are coming out. Now what do we do with these digits? We know we have a list here. We know we have a list here, which is the item price, and then you have number of items. So we do need to calculate sum or cost, something like that. Okay, let's just call it sum of item cost. Okay. That just means the same. So we will say sum of items. So what does this sum of items, what will it do? So let's just put this in here. Sum items. We didn't do anything to the sum items yet, but we would like to do something to it. We'd like to add it as we get the digit, right? So I give you 2 minutes to fill, so that this sum items works. So at the end, we know what is the total sum. So for whatever is there, after the for loop, after the while loop, basically, it should basically tell at the moment the zero is sum of items, right? We want it to be the sum. So I'll let you try this. Few minutes. Let's see. So let me quickly push it so you have the latest version which you can pull. And now let's do this. So we need one line here and one line here. Okay. Or just one line would do. What would be that one line? Let's think about it. What is the goal? Basically, whatever the user is entering, we want to go into this item price. And so if the user is entered, let's say 112211, that means we want two of these water, and then two coke, and then two of water again. So 4 water, 2 coke. And what is the cost of that? So 75 times 4 plus that, 120 times 2. That would be what should be given out. But how would we do that? So we need to write one line. Just one line of code will ensure that is done. Note what the user has entered. This 112211 can be used to get the price. That's basically what that's the goal there. That can be used to get the price. Place it in the chat. Let's see. It doesn't need to be the right attempt. You're not given a grade here, right? So we just want to brainstorm ideas. It can be wrong. Anybody done? Just give me one line, please. Just one line. Okay. Some hints would be sum of items. Yes. What should be here? Basically? What should be in place of this X? Anybody wants to try in the chat? What should be in place of the X? What should we replace that by? Anybody? Okay. Is it this hard? Is this correct? Yes or no? Just a yes or a no in the chat will be great. People, please. Am I talking to myself? It says it's 1350 is the price. Um, Not so. um, let's take this temp out. Okay. This is 610, right? 610. So item number 4, 11234, right? So it added the last item first, which is that 0 became 150. So that was item number 4. Item number 4 is supposed to be iced tea. So let's go. This is what the user is looking at, because we start from 1 in the user menu, right? But what's the price of iced tea? It's 100, but in here it's saying 150, right? So that means it's taking the other one, the next one. Then item number 3 is Diet Coke, right? Its price is 100, but it's 120, but it's taking it 100, right? So there's something wrong. We're iteratively developing this. There's something wrong, but we're going towards the goal. Okay. So what is wrong is because in here we listed I plus 1. So that for the user, they see water ID is 1. So they entered water, they want water, but what we are giving out is not water, we are giving out Coke, right? Because 1 in our world, in this is our world here, and this is the user world. Okay, this is the user world, and this is our world, the machine world, in computing that. So that's a problem. So we need to do a -1. So if we do a -1, what happens is no, both our worlds basically merge. So item 3, the user wants item 3. See in here, you see the user is saying item 3, that's Diet Coke, okay? And that's 120 cents. That's what we see here. Item 3 is Diet Coke, 120 cents. And in here, item 3 is taken, right? As 120, right? Let's go here. The Diet Coke is 120 cents, okay? Then you take out number 2, and then you're adding to that 100. Sorry, here item 3. Well, in here the item 3 is not 120, it's 100. So let's look at our list again. So it says water is ID 1, and what is the price of water? We have 10 items of water, and water is 75 cents. 2 is Coke. 3 is Diet Coke, again 120, and 4 is iced tea, 100. So, but here what we entered was 11223. So I would like to ask you the question: is this computation correct? Is 510 what the user should get? Yes or no? Okay, let's look at a very simple case. Anybody? Just one. That means we want two water, and that's 150 cents to water. Okay. Should we follow any order? Does our algorithm need any order? Let's see. No, it works without any order. So you can say, for example, 211. Okay. 211. It says 270 cents, right? And 112, 270 cents. So this is a good example of how a while loop is used with modulus and division to actually compute a sum of items. Okay, so that's that there. Then what should be done after the make selection? The make selection should be perhaps returning something if we planned for it, and that's what we planned. This is the planning, and we return the sum of items. So now, very simple, very very simple function. The number of lines is quite less, but it does what's supposed to do. Okay, so and then basically what was computed by the make selection, we basically get that sum of item actually means the total cost. So that's the total cost. And then what do? You you take that total cost and you give it to, so that's your total cost. Actually, before in our machine we were not having this total cost, right? So now we have total cost. We were assuming the total cost is 75 cents. So now let's run the vending machine. So we want two water and one Coke, and it's saying pay 270 cents. Let's say we gave a $3 coin, something like that. And basically it said your change is 120 cents, 110 cents. Okay. So so far so good. That much is working, and that's the number of coins, right? And we should also perhaps print after that is done, after the coin is printed, then we could just print the number of items. Okay, so we could just call the show menu again, or we could do this make selection. We could call this make selection again. And let's see this. So you have 112, and then you're giving this, and basically after you did that, basically it gave this number of coins, and it gave these coins out, right? And then it again printed the menu, and in the menu basically although we gave two water out and one Coke out, but it's saying that the machine still has the 10. So at the moment, the machine is very magical. It keeps on giving things, but it doesn't give track of things. We need to improve that. And how can we do that is we need to, the place where it does that, we need to update update what it's being given, what it gives out, right? So the thing is, like, we need to note that when you got these things by the user, I mean, in the make selection, the person has given these things, or let me just comment this much for now. That's something to for us to worry. So the person, let's say, does this, right? But if this person does not give the right amount, so it's if this person gives just 200, then it says you have not given enough. Basically, it comes here, right? So if we implemented the if we implemented the reduction in the number of items, so we are having this item price, but we need to reduce the items as we are giving. And if we did that reduction here, if we did that reduction here, then basically this would be assuming that you already got the money, right? So first we should give ask the user for the money, which we are doing here. Then we check if the money given is enough, so we can give the change. So the change can be even 0 if the exact change is given, right? Then we need to probably update item list. Then we can do a make selection. Okay, we need to update the item list, then we can do a make selection. Make sense? Okay, so to update item list, how do we do this? Basically, whatever you did here, that selection, you can take that selection and you need to kind of remember that selection perhaps, and then basically you need to reduce the number of items. You need to reduce the number of items for what has been updated. So that's something to think about, right? So we've made some good progress in the vending machine. And how do we ensure that these things work well, right? We need to brainstorm about this over and over again. And the other thing is, like, when the change is, let's say, not given, then basically the person doesn't give the right amount, then basically our machine just gives one chance, right? And the machine exits. Can we make this repetitive where you give that person another chance to enter the amount? Because that person made the selection already. You know what you need to give out. And now basically you are in the place where you need to give the items, but this person did not have the enough money in the first go. So now he needs to, let's say, top up the money, right? So that chance should be given to that person. So these are other levels of other things that can be added to the machine. That's something that you need to think about. Okay. Okay. So let's have a 5 minutes break, and then we continue with some other things. That would be some simple programs and a basic optimization problem, and how do we deal with it. And then we will end the discussion, the class with the introduction to object-oriented programming. Okay. So I'll let you continue with your vending machine. I'll let you think about what we have done so far and try to implement these things. Okay, let's continue. We move into. I think people are still having. I have a bit of difficulties with while loops and for loops. So let's just continue with more examples of while and for loops. So I mentioned earlier that I really liked the movie Tenet, and its Tenet is essentially a palindrome. And palindroming is when you can read things from the back. So let's see in the simple programs folder, we have an example. And again, we are going to deal with more while loops. So I mean, you would notice that what we are trying to do is what we are trying to do is a lot of algorithms, going over a lot of algorithms and examples. But the goal is like the more examples that we go over, the better you will understand the concept. So you will understand more while and for loops when you will see examples where they are being used. Whereas the for the syntax in terms of how to use NumPy, how to use other Python libraries such as pandas, visualization with matplotlib, visualization with Seaborn. There's a numerous tutorials there on YouTube and online. After the bootcamp, you can continue with those things. But here with the bootcamp, we want to kind of cover more of the essentials that help you to think how algorithms are developed and how those programming fundamentals, the fundamental concepts are used to do it. Okay. So as far as the planning ahead is concerned, so tomorrow we are going to go a bit over data processing and carry more with object-oriented programming. And then you will work on exercise 3, which is essentially converting uh, this vending machine into object-oriented programming version. Then Monday we will do a little bit more of optimization with gradient descent, optimization problems with gradient descent. We may also look at simulated annealing with traveling salesman problem. And then we will move into linear regression, very basic example of how we can work with data, how we can use very basic machine learning or the simplest of the simplest, which is linear regression, to make sense of data and to classify data. We would use another version of it known as logistic regression. And session 7 towards the end, we'll just briefly touch neural networks in the last half hour. And that's how we were going to conclude the bootcamp. And your exercise for the final exercise will deal bit of with data processing and with linear regression. So with this boot camp, you would have mastered the basic building blocks in programming and some of the key concepts in artificial intelligence, such as optimization and pattern classification, prediction, and things like that with logistic regression, neural networks, linear regression. If there's some other things you would like me to look at, we'll try. But as you know, that I'm trying to accommodate everybody here, and some people are really struggling with the programming. So it's a very diverse group here of students, and I have also diverse set of knowledge, trying to make sure that nobody is left behind. But at the same time, the people who are a bit more used to programming, they don't feel bored from the bootcamp. They already know this concept so well. Okay, so let's move into simple programs. So let's compile palindromin. First one, the number string. So it says enter a number. So you could see, and this number is a palindromin. Why? Because if you read this number from the back, then it would be, and then it says enter a string, and then that reverse is not a palindrome. So we can run this program again. That's not a palindrome. So the first function basically, it's not a function, it's just on the go without any functions. And the second one is a function. Okay. So the source is given. Basically, we can see familiar code, you know. So what is the goal here is to check if you print, if you traverse that something from the back, then that is the same as what the original is. So that's what a palindrome is. Okay. So the movie Tenet, and actually Tenet has that concept where time is moving backwards. So that's why probably the appropriate name, that name suited that concept quite well as well. So um, it's a it's a way to do this, and the other way, like this function basically looks at integers, right? And what, for example, tenet, that's a string, that's a name, you know. So can you think of names of your friends or other names that are palindromes? Anybody? Please put it in the chat, some other examples of palindromes, either numbers or strings. Examples, please. Is balloon a palindrome? Okay, so what is happening here? We are basically taking the digits out of the number that's entered. For example, if this was the number, we're going one by one, taking the digits out, and then we have this function which is reverse, and in there basically we are trying to reconstruct that number again, and at the end basically whatever is the number and the reverse of it, if they are the same, then it's a palindrome. So you see this ideas are used in that Armstrong number in a way, but in Armstrong this computation is different because that's a narcissistic number, and the computation for that narcissistic number was the digit to the power the length of the number, right? Whereas here we are just trying to reconstruct this. If you really want to see what's going on, you can print these variables very easily and see what's going on. And that's how we understand these algorithms. The more you print, the better you understand. So I'm just putting the script there. So you could see what's being printed out and how the reverse is being reconstructed. Okay, and let's do again for another number. For this number, because what the reverse was reconstructed as is 243, and that's not the same as the actual number. Okay, so we move into the next way. We put tenet, and the string is a palindrome. Tenet is a palindrome. Okay, let's try again. Um, the first number is not a palindrome and it's asking for a string. Not a palindrome. So what is happening in the second one? The second one is quite simple. Uh, there's just is asking for the string, and then you enter the string, and what it does, it just prints the string from the back. It just compares that string, and that string basically we can see, it's not, yeah, it prints it. So it says this is the reverse of the string that you entered, right? So here, that's the reverse, and the reverse is compared to the original, and that's not a palindrome. And this is a very simple way of how the reverse is printed. Okay, and you can print this using a for loop where you iterate from the back to the front. Okay, so a for loop will be something where you need to know the length of the string, and what is the length of the string. It's string, so that, so usually your for loop you start from the 0, right? But now we are starting from the length of the string. Okay, okay, let's do this. So start from the length of the string, and then we should go all the way to 0, and then we need to decrement this. So let's take this string, and then basically a string is a, and right, and that's an example of how we can print, manually. Let's just put two asterisks there to make us to help us know that we are printing this there. So kind of short form. So got upset why? Because you didn't follow the rules. So so let's put mining, and it says string index is out of range. What do you think is the problem? Yeah. Okay. We are going to, let's say, print the same thing, but from the forward to the back. Don't say this. See what it does. So it printed Rohit, right? So you could print, string what you have entered just like this, right? You could print that. That's easy, right? But you know, this is basically we're going to one letter at a time, okay? Something like this. So why is the, in this case, this is, and what's the use of? So there's a lot of tutorials as well you will find on this strings, how you can concatenate strings, how you can search in strings, how you can change things in a strings. At the end of the day, strings are arrays with the characters. Okay, strings are arrays with characters. And why do you need to do all these things? So let's say that your research area in the future, or you work in a company which is interested more in text, like what is written on Facebook, Twitter, just text mining, right? So I have one or two projects and papers are written. One was what type of sentiments or emotions are expressed by people on Twitter when COVID numbers are rising. And we did a case study of India last year. And that paper is published by PLOS ONE. You can see that in my Google Scholar profile, which just came out this year. And in there, basically, we extract, tens of thousands of Twitter data, and then we process them. And there are some libraries out there which helps to process NLTK, for example. But sometimes there are some certain things which we cannot use the libraries for if they are not there. Then you would have to write programs or functions like this. So, for example, in this text, you want to take out smileys or hashtags and stuff, right? So you would have to write while loops, for loops, functions like this to process things. So strings, I mean, in areas of programming, in artificial intelligence, natural language processing, these are very important things. So say it's not a palindrome, put my name there. So you could see that it printed, but then it printed from 5. And what happened is, because the length is 5, but we know that it should not start from 5. Okay, so that's the problem actually. So we should have then this. Now let's see. So now it printed from the back. Okay, the reverse of what you entered, right? But was it printing? So let's print this. We print I in both of them. You can put the I there. These are just examples of how we are trying to go from the back to the front. And this you can do the same for this one. You could have always converted the number into a string and done all these things. So there are many ways to do the same thing. So it says it's not a palindrome. So you could see, first it printed forward, then it printed backwards. But at the moment, so in here, basically, it's comparing the forward versus the backward, right? So if we are supposed to not do this shortcut, basically we could use something like this, okay? But we would need to kind of put that into, you know, into a special, so we just initialize another variable called backwards so that it creates the memory of the same size. And basically we can always one by one copy things in there, right? So how do we do that? So because we know it's maybe I'm not doing it the right way right now, but this is just to give an example. So if we do this, what happens? Let's see what happens. Okay, so we are reading from the back. Okay, we're reading from the back, and it didn't like the way we assigned this, so does not support this. So I myself a bit new to Python strings, so apologies there. Uh, but the basic idea is that this I should be actually a j. If and then you just say j equal to 0 basically, and then you will do a j plus equals 1. So this algorithm we could do it for this would work for arrays actually, okay, but it's not working for strings for some reason, but we just leave it here. I may come back to it later because we'll run out of time. Okay, so just leave this backward part, these things out. Okay. It says it's not a palindrome, right? So that's kind of, this is kind of working, and but what we were trying to do is do the same thing but using a for loop. Okay. Anyways, so moving forward, there's another function called palindroming, and in Python you can use this reverse function, and it's doing a join reverse. It's basically what we were what is done here and what we're trying to do here. Basically that thing is already done in the function, so it's just asking what is the another example of palindroming. So Malayalam is a palindrome, and Malayalam is a language that's spoken in Kerala state or Kerala state in India. And in Kerala, basically, there's a large population. Could be, I don't remember the population size, could be more than 40 million or so. And they speak Malayalam. Okay. And there's a whole cinema, and I watch a lot of Malayalam movies. They have a lot of movies in Malayalam. They are really good. And in India, basically, there are a lot of languages, and there are more than 14, I think 14 different cinemas or different languages of movies. And Bollywood is just Hindi, and Malayalam cinema is on its own. So that's Malayalam, and the language, and it basically is a palindrome. Okay, so we move on to Python. So I mean, we could try some more. Yeah, okay. We could put other examples there. So another language cinema is Tamil, and if it is a and more than 60 million speakers there, good movies. Not a palindrome, and maybe so that's also not a palindrome. So it looks so weird when it's printed from the back. So the first one, Malayalam, is a palindrome. Tamil is not a palindrome. Okay, so we move on to another example, which is the same thing is basically done over and over again with different ways of doing it. And again, Malayalam, and basically this is using a for loop and iterating, and then building on what is built, and basically it's an empty string, and it's adding to that empty string using a for loop. So it's kind of what I was trying to do, but doing in a more efficient manner. Okay, so the first one, it says it's a palindrome. Why? As you are building it, you could be printing it. Okay. So you can see it builds the Malayalam from the back. And if we did something like this, it doesn't matter. So now it's not a palindrome. It says no. Why? Because we added the movies there. So it built that. And the first part, of course, is the movies, but as move, and then that's the problem actually. And then I did the same with tenet. So what I was trying to do in the previous exercise actually is done here. So you need to start from, and j is -1, and then from I to the string, you keep on comparing the last with the first basically. Okay, so you keep on comparing the last with the first, and if they do not, if they are not the same, then you just break. So probably this is a better way in the sense where you do not have to do the whole thing. You just keep on converting it from the back to the front, and you do not have to kind of convert the whole list from the back to the front. But in the middle, if you cannot find that, then you exit and you say, okay, it's no, otherwise it's a yes. Okay. So an example of that would be like if we had something like this there, right? And what we can do is we can print the i's and the j's, whatever these things are in here. Okay, so print. So it's so windy today, right? So the first one is it's now saying no, but what it printed was, you could see it's ten, you know, and then stopped. Why? Because from the back to the front, these both things were saying this, and when n is not saying to e, it basically stopped. It, the loop with break, you break the loop, and it said no, it's not a solid loop. So this is quite an efficient way. So I mean, if this was like this, let's see what it does. So now it says it's a palindrome, but for that it had to move all the way back, right? But if we place something in there, then it says no. Why? Because the moment, so it's like basically it compares the last one with the first one. It keeps on comparing them, and then second last with this that one, then third last with the third one. And as it comes in the middle, it finds no, then it's like no. So the reason I'm saying this is more efficient is because you do not have to convert the whole list into its reverse order. So the thing is the amount of operations you take That's important for computation. So let's say, I mean, these are like 5 or 8 character words. But what if you are doing this operation on, a text corpus of size 1 million? So there are 1 million of these. Then basically in this one, you would be, or in the previous ones, you converted the whole thing, that 1 million from the back to the front, backwards, and then you check. But whereas in here, you are doing it as you are leaving, moving, and as soon as you find that they don't match, you do not have to convert, check the whole thing. You could be just checking the first few hundred uh, characters, and then you find, oh no, it's not a palindrome. Then there's another one, uh, same thing done with using recursion. And in the recursion one, of course, you call the function again, and recursive function to check if it's a palindrome. And basically, we assume that in this case, uh, it could be that it doesn't care if it is small or capitals. Okay, so we have Malayalam and Y here is. So whatever it gets, it converts it into a lower case, and then it does the operations there. Okay, so in here basically this is the base case is there. Okay, it keeps on checking the string length, and it basically passes the different components of the string, and that's how it's recursively comparing them. Okay, so this is all for today for, again, while loops and strings and things like that, uh, arrays. And now we move into the next part, which is the introduction to the object-oriented programming. Okay, before I do this, I push. Sorry, I have to. Okay. Okay, so that's all good. Now let's move into object-oriented programming. What is object-oriented programming? Uh, so we need to look at some into the. This is an example of an object-oriented program. It's basically object-oriented programming is using the concept of modularity, and basically it is trying to combine it. I mean, you have specific modules. What are the objects? So for example, you have a class robot, or you can have a class person. That's like a module, and in that module, in that class, basically a class is, I mean, class is just a term that's used in programming to emphasize, to implement this, but you could think of it class as a module, so it's like a robot module. There's a module fruits, there's a module banana, or there could be a module person, or class person. So let's say that interchangeably it means the same thing. Okay, so and in that module basically we have different components in the module, and the components are the functions. And in object oriented programming, the functions are called methods as well. So now this is a very simple example. We have a class called or module called robot, and you have some key components of the class, right? You have something such as name, color, weight. What are the components of the robot, right? And the functions are basically, or the methods, they are things that express some behavior, right? So in here, basically the way you define a class is by just say class robot, and you put a column. And then after that, basically you need to put the first function. And whatever is the fetch function, that is also known as the constructor. Okay, that's like a constructor. And basically the constructor is a way to initialize your key variables that defines the function. And these key variables could be in, when you are not using functions, you have using a object-oriented programming, they are, could be in globals, your globals, for example, global variables. So that's basically object-oriented programming for you. And basically we can see even in Wikipedia, there's this to read more about things object-oriented programming, and there's a lot of concepts there. There's a bit of basics about classes, objects and classes, and class computer science. Maybe a bit, this is not just for Python, but this is for general, for all languages, right? So, and that's a bit of a background reading that you can do, but not necessarily needed right now, because we can just go over it ourselves. Usually when you see the example and then you do the background reading, it will make more sense than doing that background reading on Wikipedia or any website. So here is a class, and let's try to develop some more classes, some more classes. So we see cd. So in that example of your vending machine, what are the things that will go there? Will be like number of items and things like that. They can all go there. Okay. And see, in the even in the vending machine example, the number of items, the list of items, we could have all read that from a file as well and updated it. So in here we could always read it from a file, or we could set it as it is, So we could add more things in here, weight. We could put something like height there as well. Okay, that would be very stupid, because if a robot doesn't have height, if the height is 0, then that robot may not exist, right? We cannot have a robot with 0 height. Okay. So let's say that we want to compile and run this. What is the file name? So it's called Introduction to Classes. So the name of the robot, we could set a robot. We are setting the name to the robot Tom and Jerry, and we are calling, and that's how you do, this. So you call that robot class, and we are putting in these items. So you can think of this, that the robot is initializing these to that. Okay. So that's one way of doing this. The other way is, let's see what is being done here. So in this one, basically, the robot class, it's not going to work. Okay. So a very basic class could be something where there's nothing that you are initializing. So let's do this again. You don't need to initialize it. If you don't initialize it, you don't need to put anything in your constructor. And let's see if that works. It says name not found. Why? Because the thing is, the moment you don't put anything in your constructor, all these things become useless. So there's just a class robot, and it has a function where you're just trying to print something, but that something doesn't exist at the moment. Let's say it's so at the moment it just printed the other ones. We are not there at the moment. Okay. So that's a more advanced class. Yeah. Here's a very basic one. So at the moment, it just made this class, but there's nothing in the class, right? So, and the name is basically, it doesn't have anything. So we can just say, okay, and color, there's nothing. Let's say there's nothing in color. It's initialized. These things are initialized. And there's white is, let's say, 0, and the height is 0. Okay. So that's a robot class. And we want to kind of introduce this robot. Okay, so we want to introduce this robot, and what it should do is actually print its name and properties. Okay, other properties. So this robot, weight and height. So that's the format you need to use. So in your body mass index, you could always put so let's say if we wanted to do body mass index as an example, then it would be like a class person, and the person's all these examples of the person, right? So we can do that tomorrow by looking at more examples. Okay, but let's just compile this for now. So it didn't do anything at the moment, right? But if we want to, so like this is your class, and this is like your main program. Okay, this is your main program. So basically whatever is in the class, we just called that class, and now we want to call any part of that class, then we would have to do something like r dot introduce self. Okay, so this robot is now making an introduction, and basically the introduce self gave an error because it says it has nothing as height. Right, because I had a spelling problem there. So it is saying my name is, why this robot doesn't have a name, because by default the constructor, when we basically create a robot, but it doesn't have any information, and your height is 0. So this robot kind of is doesn't have much properties. Okay, but let's say we want to give it some properties, and that's where the next one is that the constructor, we are giving it some properties by default, and the robot is taking these properties. Okay, so that's one way. Okay, the other way is where we can we can add things to the robot. In the beginning, so meaning that when we do a dot, we are accessing things in the, and now what happens is we are trying to say that the name is of this robot is Tom, and the color is red, the weight is 30. We didn't say anything about the height. So now you can see the second line, the second time. So the first introducing self, but we are now updating that robot to have these properties, and then it introduces itself again. Okay, so that's one way. The other way is rather than doing these things, we could always put another function there called something set properties. Let's say that's the name of the function. And basically you need to pass it all these things that are being passed in the constructor. So we note that all these methods of the class, you could have many methods there. No? There's unlimited numbers of methods. And they will always, the first thing in there will be the self. It's called self. Okay. So now here, and but it's very similar to a function. It's following the same style as a function, but it will be indented under the class. It's going to be indented. You could have a combination of functions and things here, like for example, the same thing, but that's not part of the class. We can say print, this is not part of class. So this is not part of it. But in here basically we can do things now. Because we are trying to place these properties in the robot. We're trying to place these properties in the robot. So whatever the name is that we are getting as a information or color, that becomes the robot's color. And height, we should give this robot some height, otherwise poor guy is not logically existing, you know. So this is example of that. Goes there. So we need to set these properties, and to set these properties we'll have to we can make another robot. Okay, so either you set properties directly, or we can have a R2D2 or in Star Trek. Okay, so right, and then now R2 dot properties, set properties. Okay, so this robot is me, and my color is the controversial topic these days, but I will say it's hard to define my color, but brownish robot. And weight, something everybody hides, but I don't really care that much. So because the things that are strings and the height is, so if you run my BMI, you know that I'm really a bit unhealthy actually, to lose a bit of weight. So that's my weight and height the last time I checked. So it's a robot version of me. So these are my properties, and then I want to introduce myself. So I am the R2. Okay. Okay. Let's just compile one thing at a time. So it says I already have an error. Why? Because when you're calling, you shouldn't put those things there. You couldn't put a column. So at the moment, this R1 that was there, it has introduced itself, and but the robot 2, these things have been set in the robot 2, but we don't see anything printed because we just go into the more advanced class. Okay, but in the basic one we don't see anything printed. Why? Because we did not introduce this robot. Now we need to introduce this guy. the name, and to introduce this guy, we need to point to that guy. So it's like, okay, I'm introducing that guy. Okay. Okay. So that's what basically the oriented programming is all about. So my name is Rohit and I'm from, okay, those are my details. That's that robot, and we can add these robots. We can have multiple robots. We can add more functions to this robot. So the in the this robot, when we define this robot, it doesn't have anything that it starts with. It doesn't take any information. But now about a bit more advanced version is that robot is now initialized with a constructor. And what that I mean, there is also, this is a constructor as well. Okay, that's the constructor. But this version of the constructor is automatically we are giving it some properties. So when you call this robot here, the second one, basically it says Tom and Jerry, and then we have another R2. Okay, let's, because we have them in the same, we call them R3 and R4. Okay, so this robot, we can call it another example. Okay, this is another type of robot. We can say that's an advanced robot. Okay, so that's an advanced robot. And see, whatever is the name, basically we initialize this is, and then this part is again the main. Okay, so that's the main. So here this function was never called, so we don't see this same part of the class. Okay? Function is never called, it's just defined, it's just sitting there. But now we go into the next one, the more advanced one. It's being initialized with all these things, right? And we don't need to have a empty one because we automatically initialize. So basically kind of the more advanced one is doing the same thing but initializing. So this is just an introduction to, you know, object-oriented programming. So you could have any type of class, like you could have a class, let's have some more examples. You could have more classes. So we could have like a class square, okay, right? Class square, and all these properties can be in the class square too, right? The square can have a name, it can have a color. Okay, let's take the square name out. Okay, let's just do color. Square that does not need to have a weight. Okay, so it could have color, it could have length and width. Okay, so we can just set this a square, class square, and it has a length, color, and it has length, these properties, and it has width. Okay. Right, so introduce this square. Okay, I will just print color, and it will print length, and it will print. Okay, so that's that there. And what we want is this square to be defined. So we say S square 1 is a square, and there's another square 2. So that's square 2. Okay, so it has length. So we give whatever is the color. The color is let's say red, and its length is 20, and width is okay. Length is 10, and width is 10. Okay, and then there's another square which is blue. Right? So we have square 1, and there's a square 2 which is blue, and it is yes blue, and its length is 20, and width is 30, 20, 25. Okay, so now we can do a S1. We introduce these squares. And S2. So we want to see what are these squares. Okay, so let's it's got a bit width. I have width, then I did a width. What is the error? It says weight. Why? Because there's no such thing as weight, there's length. Okay, so that's the square. Okay, so this is a class, it's on its own square. So let's say that we want to add to compute the length and width. We want to compute the total area of both square. So total area should be, let's say, area of square 1. So it could be area of square 1 plus area of square 2. So there are two ways to do this. Okay, so one way is okay, I'll take another few minutes. I know we run out of time now. So one way is we access these things directly. So we do S1 dot length times S1 dot width, then plus, so this thing is done. So that's the area of square 1, right? Plus the area of square 2, S2 dot plus S2 dot width. So this basically will give us the total area. So that's all. Any questions or comments so far? Any part that is not clear to you? Maybe put it in the comments, then I can go by the view. So that is the square. Okay, I'm just so sorry. I was not able to see your chat, so I see your chats now. Actually, thank you so much, Ansh and Hillary and Tarun Roop, for placing those comments. Okay, Ansh is asking about this one. Right, thanks Tarun Roop about the reverse part. Ansh is so with self we are defining features, attributes of the class. Yes, self we are having features and attributes of the class, and basically we are putting functions, right? So this is one way to do it, but typically in object-oriented programming, this is kind of frowned upon, especially in when you're doing C++ and Java, these things need to be part of class, and they don't want you to access them from the main. Why? Because this kind of is not secure, meaning if your class is about a person and that person has some password or things, you don't want it to be accessed by other people, by the main. So usually these things can be protected. In other languages such as C++ and Java, it's automatically protected. But in here, these things are publicly accessible. Publicly accessible means they are being accessed by the main, right? So, and the functions can be, or the methods also known as methods in this case, they can be returning things, okay? With multiplied by self dot length, okay? So you return area. Okay, I have another meeting now, so I would have to run. But basically, this returns the area, and then we can say that okay, the total area is this. Call this. So we just say s dot s1 dot total area, and then there is plus the s2 dot total area. So this is basically again giving us the total area, another way of doing it, kind of like that. So this kind of brings us to the end of introduction to classes. So there's another way of doing it, and it seems that there's some slight error, but that is because of the variable being updated over and over again. So we'll go over this example. We'll continue with this example tomorrow. Okay, please, anything else you want me to look at, message me and I will check that tomorrow. Thank you so much.